Welcome to homework.
Hello everyone, today we're doing chapter 29, problem 36. This problem tells us the equation how to calculate PIs for acidic and basic amino acids. And essentially, the PI of an acidic amino acid equals the pKa of the alpha carbon carboxylic acid, so the carboxylic acid off the backbone, plus the pKa of the carboxylic acid of the R group over 2. And the PI for basic amino acids equals the pKa now of the alpha amine off your backbone plus the pKa of your side group or the side chain R group amine all over 2. So using this logic, it asks us in A, indicate that which pKa values you must use to calculate the PIs of the following amino acids. So the first one is glutamic acid. So glutamic acid, as the name suggests, is an acidic amino acid. So right off the bat, we know we have to use the pKa of the side chain R group. So for glutamic acid, being the one-letter code being E, the pKa for the side, the backbone carboxylic acid is 2.1. And this makes sense because in physiological conditions, it's going to be deprotonated as pH is going to be above the pKa. And now the pKa of the side group carboxylic acid is also very low, being at 4.7. And in order to find the PI, we just divide this by 2. Now for the second amino acid, lysine, so that's K. Well, lysine is the basic amino acid. The side chain has a terminal amine group after 4 carbon linker. So we know that we have to use the basic amino acid equation. So the pKa of the basic amino group off the side chain or off the backbone, is pretty high, 8.95, and that makes sense because now the pH is below the pKa, meaning that this is going to be in its protonated form in physiological conditions, which makes sense. NH3 is going to be in this protonated form, plus the pKa of the side group, which is going to be even higher, 10.53, divided by 2. Now the third amino acid in this question is arginine. So arginine, once again, is a basic amino acid. So just like before, we take the pKa of the backbone nitrogen being similar to that of lysine, but just slightly different, of 9.04, plus the pKa of the side chain amino group, which is 12.48, divided by 2. So now, using these numerical values, these quantitative values, we can figure out the qualitative values for question B and C. So in B, it asks us, in general, how does the PI of an acidic amino acid compare to that of a neutral amino acid? So you can kind of imagine that a neutral amino acid, you can say the side group is going to be, the PI in neutral amino acid is going to be similar to that of the pH at neutral, which is going to be around 7. But now, for example, let's look at the acidic amino acid. So here we have approximately 2 plus 4, which is 6, divided by 2, which is approximately 3. So right off the bat, we see that PI of an acidic amino acid is going to be much lower than that of a neutral amino acid. And now on the other hand, what we have is the PI of a basic amino acid. And what we see here is that for either one of these, you could say approximately 9 plus, you could say almost 10, a half, 11. So we can just approximate that to being 20 divided by 2. That's going to be just under 10. So we can just say it's going to be around 9.5. So that's going to be higher than the PI of a neutral amino acid, which actually gives us the answer for part C, being how does a PI of a basic amino acid compare to the PI of a neutral amino acid? So basic amino acid PI is going to be above the PI of a neutral amino acid, and acidic amino acid is going to have a PI below that of neutral amino acid. And that makes sense. Why? Because in physiological conditions, your acidic group, such as your backbone carboxylic acid, is going to be deprotonated because that pH 7 is higher than the pKa of, or PI of 3. But then on the converse side, your basic amino backbone moiety is going to be pronated because the pH is more acidic than the pI at physiological conditions.